Here the Euler's tosine function, here is what the Euler tosine function values look like for small values of n. The dotted red line is the line fn equals n minus 1. This is the blue curve and this is the red line. You can see the dotted red line is the line where the function of n equals n minus 1. Here the 4 points under which we will continue some more important facts of the number theory. The first is prime and composite numbers. The second is selected topics from the number theory. Third, the greatest common factor and the least common multiple. And the fourth is Fibonacci sequence and the golden ratio. Also the perfect numbers, deficient and abundant numbers, amicable or friendly numbers, Gold-Bass conjectures, twin primes, Fermat's last theorem. Here are some examples of the perfect numbers. A natural number is said to be perfect if it is equal to the sum of its proper divisors. 6 is perfect because 6 is equal to 1 plus 2 plus 3. Here the important line to be considered, that the perfect number if it is equal to the sum of its proper divisors. Like here 6 is divisible by 1, also by 2 and by 3, and if we add 1, 2 and 3 it gives 6, so 6 is perfect number. 8 is not, because 8 is divisible by 1, by 2 and by 4, but if we add 1 plus 2 plus 4 it does not give the 8, so here 8 is not the perfect number. The deficient and abundant numbers. A natural number is deficient if it is greater than the sum of its proper divisor. It is abundant if it is less than the number of its proper divisors. We are just reviewing again. A number which is natural is deficient if it is greater than the sum of its proper divisors. This will be clear by example.